Hi guys. So let's see how we can solve these particular equations. So to solve this equation, the first thing we're going to need to do is need to expand everything that we have. That is 3 times x here should give us 3x. 3 times 5, that should be 15. This is equals to 2 times negative 6 is negative 12. 2 times negative x is negative 2x minus 2x. Then this becomes 3x plus 15 is equals to negative 12 minus 4x. We group like terms, hence this gives us 3x. This can come to the other side and become a positive. This is equals to negative 12. This can go to the other side and become a negative. So 7x is equals to negative 27. So divide both sides by 7, hence the value of x is negative 27 over 7. So that's our answer for x. So to solve this equation, the first thing we're going to do is on the left-hand side, let's add the fractions. This is 1 over 1, meaning that the LCM will be 3. So 3 into 3 is 1. 1 times the numerator there, we'll have m minus 2. 1 into 3 is 3. 3 times 1, you just get a 3. All this is equals to 2m over 7. This will give us m plus 1 divided by 3 is equals to 2m divided by 7. Negative 2 plus 3 gives us the one that we have there. We can decide to cross multiply so that the 7 multiplies m plus 1 and the 2m multiplies 3, giving us 6m. This here will result in 7m plus 7 is equals to 6m. So 7m minus 6m is equals to minus 7. Hence, the value of m simply goes to negative 7. So we can even try to prove it by simply replacing m with a negative 7. So let's see. We'll have negative 7 minus 2 over 3 plus 1. Let's prove that this is equals to 2 negative 7 over 7. So this here will give us negative 9 over 3 plus 1. This side is negative 2. So this will be negative 3 plus 1, which is just the same as negative 2. So this makes our answer correct. So how can we solve this equation? So the first thing we can do here is we can cross multiply. So this will multiply that, giving us 2y minus 6 in brackets multiplied by 10 minus y. This is equals to 5, which is multiplying y squared plus 6y plus 9. So if we expand on this side, we'll have 2y times 10 gives us 20y. 2y times y gives us 2y squared. 6 times 10, that is a minus 60. 6 times y to be a positive 6y. All this will be equals to, if we expand this side, same thing, we'll have 5y squared plus 36y plus 45. So at this stage, it's just a matter of grouping like terms so that we solve this quadratic equation. So grouping like terms, on this side we have negative 2y squared. We can bring this to the other side, it becomes minus. We have the 20, we have the 6, that gives us 26. This side we have 36y, so if it comes this side, it becomes minus 36y. We have the 60, and the 45 can also come this side. All this is equals to 0. So this here becomes negative 7y squared. When we subtract these two, we get 10y. And subtracting these two gives us 105. And all this is equals to 0. So now with this quadratic equation, we can first take divide everything by -1 so that we just remain with positive values. That is 7y squared plus 10y plus 105. All this is equals to 0. So to solve this equation, we can use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, and all this is over 2a. So let's do the substitutions. So y will be equals to, our b is 10 square root of 10 squared minus 4. The value of a is 7, and the value of c is 105. So that's what we get. Now all this is over 2 times a, so that is 2 times 7. So the value of y will be equals to -10 plus or minus square root of, here we'll get 100. Then now let's multiply 4 by 7 multiplied by 105. So what we get is 2,940. And all this is over 14. So -10 plus or minus. So in the root there, we'll get a -2840, and all this is over 14. So we can clearly see that what we have here is a complex root, because the negative, we cannot find the square root of a negative number. So we're going to go into complex numbers. So to find the square root of this particular number, we'll simply say the square root of 2,840 is 53.3. So y is equals to -10, 53.3i, because now we've gone into imaginary numbers. So if that's the case, our answers will be complex, of which the first answer will be the positive, the other answer will be the negative. So we can present our answers as, the first answer will be -10 plus 53.3i divided by 14. And the other answer will be y is equals to -10 minus 53.3i over 14, of which I is just coming from the group of imaginary numbers, and our final answer is in terms of complex number. So this is what we have. You can also go ahead and separate them by separating both parts like this. So y can be equals to, so 10 over 14, let's just write it as a decimal, is 0.7, so -0.7 plus, so 53.3 divided by 14 gives us 3.8. So 3.8i as an imaginary number. The other value, again, to be -0.7 minus the same thing, which is 3.8i as an imaginary number. So there we have it. These are our two answers for this particular equation. But in an event that you have not done complex numbers, you can just end here and just conclude that this particular solution is not applicable. But if you have done complex numbers, you can proceed and find them like that. So thank you very much. So how can we solve this particular equation? The first thing we can do is can add the fractions separately on both sides. So on this side, this is 1 over 1. This side, it's 2 over 1. So our LCM here will be z plus 3. So z plus 3 into this, we get 1 times that, we get 2z. 1 into this, we get this. This times 1 will simply be z plus 3. Same thing here. The LCM will be z minus 10. So this into this, we get this times 3. That is 3 multiplied by z minus 10. 1 into this, I think I've made a mistake. This into this is 1. 1 times 3. So that's supposed to be 3. Sorry. This into this is this times 2. That will give us 2z minus 10. So this becomes 3z plus 3 divided by z plus 3, like that. Then this is equals to z minus 10. The numerator there, we just have a 3 here, plus 2 times z, that is 2z, 2 times 10, that is 20, like that. So on this side, we can now, first of all, here we still have some like terms to add. So 3z plus 3 divided by z plus 3, this is equals to 2z minus 17 divided by z minus 10. So we can cross multiply now. So 3z plus 3 multiplies with z minus 10, giving us 2z minus 17 multiplying with z plus 3, like that. So if that's the case now, let's expand. So 3z times z, that is 3z squared. 3z times 10, that is 30. 3 times z, again, that is 3z. 3 times 10, that's another 30. All this is equals to 2z times z is 2z squared. 2z times 3, 6z. 17 times z is 17z. And then 17 times 3, that is minus 51. So let's group like terms. On the left hand side, we have just z squared. Remember, if this 2z goes that side, it will be 3z squared minus 2z squared, that is just z. These two here will give us a minus 27. Like that. We have a 30. These two here will give us a minus 11. When it comes to this side, it becomes positive 11. Plus that 51 that's remaining. All this is also 0. So z squared, this and this will give us minus 16z. The 30 and the 51 should give us a positive 21. All this is equal to 0. So let's solve it using the quadratic formula. B squared, that is 16 squared, plus or minus 16 squared, sorry, this is supposed to be only, minus 4a, our c is 21. All this is over 2a, which is just the same as 2. So z will be equals to positive 16 plus or minus square root of 256 minus 84. And all this is over 2. Okay, so z is equals to 16 plus or minus. So 256 minus 84 is 172. If we take a root, we'll get 13.1. All this is divided by 2. So the first value of z will be 16 plus 13.1 divided by 2. We're getting 14.6. And the other value of z will be 16 minus 13.1 divided by 2. We're getting 1.5. So these are the answers for z. So I hope it makes sense. Thank you very much.